Good afternoon, everyone. Thanks for coming. I hope you're all enjoying NDC. I know it's day 2. I know I'm probably between you and the commute home. So I really appreciate you coming and hearing more about the state of mobile development with JavaScript. My name is John Bristowe. I work for a company called Telerik, otherwise known as Progress. We were recently acquired, so if you weren't aware, if you were a former customer or customer of ours and weren't aware that we got acquired, that's why it says Progress up here. But we make developer tools, UI kits, a whole bunch of other things for developers. We have over 1.6 million developers using our stuff. We hope you're a customer of ours. If not, you will be soon. So at least I assume. In this session, I'll be covering the state of mobile development. And in particular, I'm going to focus on mobile development with JavaScript. You may notice that the title of this talk doesn't specifically call out hybrid. It is something I will be talking about, but that's intentional. Hybrid is just one of many ways in which you can actually target mobile development using JavaScript. So if you're a mobile developer today and you're wondering how you can leverage maybe JavaScript, or vice versa, if you're a JavaScript developer and you've never touched mobile before, this session will help you understand what tools are available, what the state of the union is right now in our industry, as well as some of the techniques and processes you can go about doing it. I am going to try and do as many demos as I can. Some of them may fail spectacularly, so your understanding is much appreciated. I'm a bit at the whim of the internet here, so if I'm going to download NPM packages and things like that, and it goes slowly, I might just kill it. So anyways, we'll try. We'll see. JavaScript, everyone's favorite language, I assume. It's really been interesting to watch the evolution of JavaScript. I've been in this industry for a long time. I started cutting my teeth way back when, in the early 90s, on software development, and JavaScript was one of those early languages that I did way back when. And it's been interesting to watch the evolution of JavaScript over the past number of years, where it's been sort of this toy language for kind of adding dynamic elements to web pages, and now it's actually used for very complex systems, both on the client and on the server side. And this is obviously best exampled by where we've come from and where we are now. There's just a lot of complexity inherent in JavaScript today. And I don't think that's really a fault of the language. The language itself is evolving quite nicely, I think. If you look at ES6 and beyond, I think what's really been problematic in this space is just the amount of churn and the amount of adoption, the amount of frameworks, and the amount of basically open contributions that have been going on. But the reality is doing mobile development with JavaScript is a bit tedious. It can be a bit problematic. There's a lot of problems inherent with this. If you've never watched this movie, this is Christmas Vacation. This is one of my favorite scenes, and this is where cousin Eddie basically walks up to the mobile and trashes it in one go. If you've done any mobile development with native, you can shoot yourself in the foot definitely, but with JavaScript, it's especially awesome how well you can actually trash your own app space and crash spectacularly. But that being said, I mean, it's not just mobile app dev with JavaScript for hybrid and other sorts of domains. We've also have sort of competing spaces for this, HTML5 in particular. A lot of people have been talking about HTML5 for a long time, and basically what's available there. You may have heard of this term called progressive web apps, which is being pushed heavily by Google. At the latest I/O, they talked a lot about this. And really, it's a culmination of things that have been going on in the browser, where we actually have access to things like file I/O and other things that have been basically closed off to us in the web space. It's getting a lot better. But the reality is it's still a bit of a challenge. When we talk about mobile app development, it's also a challenge in terms of getting an app that is actually working well and addresses the need of the customer. And so when you target this using native technologies like UWP or Objective-C or Java for each of the platforms you wish to target, i.e. Windows Phone, iOS, or Android, it has a lot of twists and turns. It can be very complex to build something native, and there's a lot of maintenance that goes into that. If you are using a framework like PhoneGap Cordova, it does give you sort of a clear path towards one direction, but the end result of it may not be as beautiful or as performant as you may have liked. So there are some sort of competing concerns here when looking at this space. So, truth be told, there's a lot of stuff involved in this, and there's a lot of things that you need to look at. So, I understand if you're confused or frustrated. I've been there for a long time, and in fact, we build tools to help ease your pain. But the reality is, if you're going to target this space, there's a lot of tools to install. There's a lot of frameworks that are out there, and so this is just a subset of some of them that you'll have to use. Now, just so you're aware, I have all these installed. But there's more than just this. This is just sort of some of the ones that you may have heard of. There are many, many other frameworks that you can also integrate with this. And yeah, just one of those things, I guess, you'll have to explore. So if you're going to tackle this space, make sure you have a large hard drive and a lot of VMs. That tends to be important. But looking at this space, it's not too bad. So what are we talking about here when we talk about mobile development? Well, in terms of native, obviously, this is where you're addressing each platform with the runtime, the SDK, and the languages that are basically pushed by each one of the product vendors. So in the case of Apple and iOS, that's Swift or Objective-C. In the case of Android and Google, that's Java. And in the case of Microsoft with Windows Phone, etc., that's .NET. Now, when we talk about targeting mobile development using JavaScript, we actually have this nice sort of scenario where we can cross-cut every platform with this sort of universal language. And really, the design decision comes down to what platform do you want to target, right? It doesn't actually matter. This sort of debate of do we have to target Android or iOS kind of goes away. So to kind of lay the land of what this looks like from a high-level perspective, I'd like to go over some of your options. So at the bottom, we have really this spectrum of what we can do. Traditionally, and I say traditionally up until relatively recently, like in the last few years, you've had native on one side, where you have the native technologies pushed through SDKs. On the other side, you have web, which is very broad, but in some cases hindered by restrictions of the browser. And somewhere in the middle, you have this large gap in between called hybrid. Hybrid is where you typically see a lot of frameworks like PhoneGap, Cordova operate. In each one of those, you have app stores. And in case of the web, you have the world's largest app store, which is basically a URL. So that is the world's largest app store in a sense. Underpinning all of these, of course, are the operating systems. And then on top of each platform, of course, you have different runtime characteristics, various sort of SDKs, things that you need to target. And then you have applications, which are your packages that encompass the various assets that comprise your application. So in the case of native, it's relatively simple. In the case of hybrid, it gets a little bit more complex because now what we're talking about is a sort of native container that encompasses your web view. So hybrid applications are typically ones that incorporate a web view somewhere in the app. In most cases, it's going to be a full screen web view. So if you're not aware, apps like the NDC Sydney app and others that you may have used, there are many that incorporate hybrid. We'll use this model where you have a web view at full screen, and then you have various assets running inside of that context. Now, the way that this operates is that you'll have a set of what are called plugins that interact with the operating system. In the case of Cordova, they come with a number of them built into the SDK itself. You can create your own as well. So these allow you to interface with the underlying operating system in a native way. And in the case of web, this is where HTML5 operates. And we actually have a lot of power and flexibility here. There's more and more APIs available on the HTML5 side than people realize. So things like file I/O is possible. But again, it comes down to browser support. So one of the things that comes up often is, what about this divide between native and hybrid? Is there a gap there that can be serviced by a solution? It turns out there is. And this is something that I'll talk about later on in the second half of this presentation, which we're calling hybrid, native hybrid, basically. So the idea is we want to get the benefits of web-based sort of development, but leverage the native APIs without all of the sort of nastiness that goes along with using plugins. So how does this one work? And how does that also address other aspects like progressive web? Well, in both cases, it's a similar sort of model. You have an operating system, you have app stores, and you have ways of addressing them. In the case of native hybrid, you have various frameworks. React Native is one, NativeScript, which is what we build, is another. And in that case, instead of servicing web views, we actually have JavaScript running within the VMs that are hosted on each platform. So in the case of iOS, Android, and Windows Phone, potentially, you have each of the JavaScript VMs that are processing your code. And in that case, there's no Webview. So the idea here is we want to invoke native APIs directly through a bridge. And that way we get native performance, you get less janky apps, and it turns out to be really nice. In the case of progressive web, this is highly, very slanted towards Google and Android. The idea here is that you'll have still running within the browser your application, but there's these concepts like push notifications and service workers that go along for the ride. But you can get almost to a near native experience with that as well. In the case of this scenario, on the right with yellow, you have probably the most reach. Progressive web is a little bit debatable, but this is where you have not as much sort of proprietary things going on. In the case of blue, this is where things get more interesting. So there's a lot of things that are going on there. So this is the lay, the 50,000-foot view, the lay of the land of where things sit today in terms of building apps for mobile platforms. Now, if you want to read more about progressive web and what Google's doing there, there's a website you can go check out. It's up on the developers' website for Google. They talk very extensively about this. There was a lot of news and interest about this at Google I/O. They recently had the summit for progressive web apps as well. So you have a lot of choice there. But if you're kind of more interested of like finding out what you can do and what frameworks are available and what platforms you can target, there is this website as well, which is the Mobile Frameworks Comparison Chart. In fact, let me just go ahead and show you that now. This one's actually quite a useful resource. So here you can go and answer a series of questions that will allow you to basically say, well, I want to target various platforms, and it will filter down the list of options you have available to you. Now, a large chunk of these frameworks that are listed here are UI frameworks. So things like Kenda UI, which we build, others as well. You can also specify things like targets, whether or not you want to create a native app, for example, and other things like that. So this will give you a breakdown of what's available there. So if I wanted to, I could take a look at, say, building a hybrid app, and I could take a look at my options that are available to me there. So lots of options. And if I wanted to, I could drill down into one of these like Xamarin and see what's available to me there. So this is a website you can go check out if you want to do a cross comparison of things that are available. So let's address the first topic, which is hybrid. So in this instance, we're basically trying to build an application that utilizes a web view. So the nice thing about this scenario is you can target both iOS and Android on a PC or a Mac. It really doesn't matter. You have developer environments that are both supported. And also, in addition to that, you can target pretty much any IDE you wish to do. So whether it's Sublime Text, Atom, Visual Studio Code, etc. And the idea here, and the nice thing about this is that because we're leveraging a web view, you can make updates and see them inline within the app itself. It's a very seamless, very productive development environment. And obviously, the canonical sort of target framework for this is Cordova. So Apache Cordova, otherwise known as PhoneGap, there was a name change for various reasons. This is basically the framework in which you can actually create these applications. So let's go ahead and just create an application that does just that. So I'm going to jump back over here, and I'm going to jump into some demos now. So let's go ahead and create an application. So I've downloaded the Cordova CLI. The way that you can you see this in the back, by the way? Do you want me to pump it up? Okay, good. So you can download the CLI via npm, and then from there, you just simply utilize the CLI to create an application. So this is the CLI for Cordova. This is basically how you create apps. So you can go ahead and say Cordova create, and then you can give it basically a name and as well as a reverse URN for the domain space. So I'll go ahead and call this one hello NDC Sydney 2016. I'll give it a domain space here. Because I'm going to be targeting a device where I need to basically have a signature, a provisioning profile, and things like that for creating an IPA, which is the app package for iOS, which I have here. I'm going to utilize my domain here. And I'll go ahead and call this NDC. And then I can give it a number of config options here if I wanted to as well. So let's just go ahead and say NDC 2016. So it's going to go off and create this Cordova project. As you can see, I've actually done this a number of times. I've got a lot of projects in here. This is the fun part of being involved in some of these demos. So I'll go ahead and create that and jump into this domain, or this directory. And if we go ahead and take a look at the directory structure for this in VS Code, let's take a look at what's been created. So on the left-hand side here, this is our directory structure. There's a bunch of folders here, some of which you don't really need to worry about too much right now. The one that I want to draw your attention to is this one, the www folder. Inside there, you'll find the assets that comprise your application. Now, when you create one using the Cordova CLI, it'll create a very bare bones application. So this will have a sort of look and feel that doesn't represent much, right? There's not really that much to the application itself. But there are some inherent things involved in Cordova development that you need to be aware of. So things like there's a different event model that occurs, there's certain security constraints that are involved, how you install plugins, et cetera. These are all important things to note. Where you install plugins, for example, will reside in this folder here. The platforms folder, for example, is where you'll see their builds be executed and create things like Xcode projects. Yes, you do need Xcode if you're going to build against iOS, for example. It's just a sad reality of the story. So let's take a look at how this can actually occur. So I'm going to go ahead and execute Cordova. And then for here, I can go ahead and say build iOS. But before I do that, I go ahead and add the platform iOS. And what this will do is basically provision for me the environment. It will stub out the project template for iOS development. And once that's done, I can go ahead and target iOS. This will utilize the command line tooling available for Xcode. So here you can see it's gone ahead and established a bunch of config settings. It's created for me a path under platform/iOS. And now we can go ahead and build this. So we'll go ahead and say build iOS and provide the verbose flag. The reason why I'll do that is just so you can see basically all the work that's being done targeting the underlying command line tools for generating essentially an IPA. So the IPA, or the app package, if you will, for iOS is generated in this location. If we go ahead back to our platforms directory and expand iOS, there you can see all the assets that have been generated. You'll notice that things like the www folder still reside in that location. I can also go ahead and then execute this against a variety of targets. So the way I can go again, a list of these targets is by saying Cordova run whack list. And you'll see I see not only my iPhone, which is here, I have tethered by a USB. I also have a number of iOS virtual devices as well that I can target as well. So if I wanted to run this on a virtual device through the Xcode simulator, I could go ahead and do that if I wanted. So I can go now and say Cordova emulate iOS. And this is going to go ahead and launch the iOS simulator, which is here in the background, and then deploy my IPA to that environment. So essentially, basically showing you how that comes about. And there we go. Now here, I mentioned earlier, there's a different set of characteristics. Like it's like web development. You have angle brackets, you have JavaScript. It's very similar, but there's different events that occur. So rather than on document ready, you have on device ready. You also have the notion of plugins as well, which comes into play. Those plugins are available up on two websites. Actually, there's a number of websites there that you can check out. One of which is up on Cordova's site itself. This is a site that they have where they provide a whole bunch of plugins that have been written. So plugins are things like being able to access the camera, the accelerometer. These are ones that actually come free for the ride. But other plugins might include things like Firebase integration or integrating with SQLite. These and other types of plugins are available there. Until recently, the plugin story wasn't great. In fact, if you were doing Cordova development back in the day, the Cordova plugin story was go to this GitHub repo and hopefully there's a README file for the plugin that's been written, and we don't know the developer, but it's fine. Just go ahead and use it. The reality is that a lot of those plugins would be broken, they would be old or deprecated. And so one of the things that we've done at Telerik is we have this sort of verified marketplace of Cordova plugins, which you can go check out at plugins.telerik.com. I'll show you this quickly. So if you go here, you'll see we have this marketplace of plugins for both Cordova and NativeScript. And the reason why I mention this is because one of the challenges of using a plugin is not just getting it integrated, but also finding samples, right? Finding code snippets and things like that. So for example, the action sheet is a pretty common sort of pop-up that you'll see in native apps. And so what we do here is not only do we provide sort of documentation for it, which could be missing, we also provide code snippets. And even down here at the bottom, we'll provide screenshots of how to use that. Now, to utilize a plugin, you simply load these in via the CLI. So let's just see where I am here. So I'll go ahead and add a plugin. So the way you can do this is through the CLI, say plugin, add, and then it will basically ask you for what kind of plugin do you wish to add. So I can say, let's add the camera plugin. And when I do that, it will go ahead and download that via NPM and install it and make it available to me. And once it's available to me, I can then leverage that through a series of API calls. Now, to show you how this operates, if we take a look at, where is it here? Not you. This is when you got lots of windows open. So what I'm going to do here is just navigate to another location that I have. I think this is it, yep. So this is another project. This is like the Julia Childs. Here's one I created earlier type scenario. Here I've gone ahead and integrated the camera plugin. And if we take a look at an example here, you can see that the way that plugins typically work is they'll annotate the navigator object. So the navigator object's a very sort of common object found in JavaScript development in the traditional sense. And what they do is they supplement that object by annotating it with additional classes. So in the case of the camera plugin, there's an object there called the camera object that you can go ahead and interface with. And when you call an object method like getPicture, it will prompt the UI itself to spawn the native picture integration API on the platform you're targeting. So if we go ahead and deploy this to my phone here, let me go ahead and bring up my phone through the magic of QuickTime. And if we go ahead and launch this app now, what we have here is just a very simple set of inputs at the bottom. Those are represented by those buttons that you see at the bottom. And so what I can do here is I can say capture photo with image data. And what this will do is allow me to, it will automatically integrate with, sorry if no one wants to be seen, I apologize. I'll just do this sort of really cool retro thing. But it will allow me to basically take a photo. I'll take a photo of my screen here. And then I can utilize that photo and display it, if I wish, to a variety of locations. So I can put it back on the screen here. I can put it, I can utilize that data as an image URL. It really doesn't matter. I can also select images from a photo library, for example. There's a whole bunch of things that I can do. So these are things that you can interface with. Now the calls for these APIs are pretty simple. Via JavaScript, it's not terribly difficult to actually interface this with the native API. This is the GetPicture API you just saw when I took the photo. If I wanted to get a photo from, say, a location on disk, so we have these sort of well-defined types for things like a saved photo album or photo library. I can get those locations by simply calling getPhoto, which is here. And so we have on this camera object the GetPicture API that allows me to target a URI location, which is that override there. So that's basically interacting with that native API, and that's basically how Cordova does its heavy lifting. Now there's a bunch of APIs that you can target for this, but essentially that's been the story for targeting hybrid development for a very long time. And in fact, that's really like the essence of targeting Cordova. And there's a whole series of frameworks that you can use as well for targeting the front end of this, which I'll talk about a little bit later. But one of them you can use is like one that we write, which is called Kendo UI. There's a whole series of widgets that you can use for this as well. And these are native sort of controls that you can embed on your pages that will allow you to integrate front-end controls that look and feel like the native components themselves. But the reality is that these are themed according as CSS. There's nothing magical going on here. These aren't native controls. They're just made to look that way. So these are a bunch of ones that we ship as part of Kendo UI. And I'll have to rate it on my, you can go ahead and check it out. It's not worth kind of drilling through that. But that's essentially how you can go ahead and create these applications really simply. Now, there's a whole series of other tooling that you can use as well. So in the case of my previous example, so if I go back to the previous example I showed you earlier, there's a tool that you can use called CDV Live, which gives you this sort of ability to trigger live updates as you're interacting with the environment itself. And it will set up this endpoint that you can go ahead and interact with these endpoints and get live updates occurring as you're changing code. So it will set up a system watcher for you to track changes and basically utilize those changes directly with the emulator itself. So that's something else you can use as well. So in terms of hybrid itself, Cordova is one example. That's something that you can target as well. A very popular framework that you may have heard of is Ionic. Ionic actually is a wonderful framework if you're leveraging strictly hybrid with Angular. That's its claim to fame, which is basically we leverage Angular very well, and we have a whole series of controls that you can use. So let's take a look at a demo of that as well. So I'll jump back here, and let's go ahead and create a new application. So the way that this is done is there's a CLI that you can install as well. So if you say npm install, oh, I'm sorry. Sorry, I was in presenter mode and it doesn't always switch over. Thank you. So you can npm install Ionic, and this will give you the command line tools for Ionic itself. So Ionic has a similar sort of development model where you can go ahead and say Ionic create, etc., and it will go ahead and create for you, stub out these projects for you to use. So a quick example is I can go ahead and say Ionic start, and then I can create an application like NDC Ionic is rocks. And then it takes basically another parameter here, which will say what kind of project do I want to create. So I can say tabs, for example, and this will basically create an application that has a series of tabs located at the bottom of my interface. And we'll see in a second how this operates. But effectively, Ionic has a series of directives that it's created that emit HTML for basically creating these sort of native-ish looking interfaces. But as you see underneath the covers, it's just HTML running within a full-screen web view. So it does use Cordova as part of this, so it's initializing that as part of that process. There's a whole series of other operations you can conduct as well. There's things like being able to do live updates. There's a whole bunch of things as well. So once that's initialized, and again, we're at the whim of the internet here, so I do apologize. But once that's all done, we can go ahead and build and then emulate this through the emulator. So it's gone ahead and added iOS. You can go ahead and add other projects as well if you wish. So I'll go ahead and say no, and then here I can go ahead and say build iOS. And what this will do, oops, I need to navigate into NDC rocks, and I'll say build iOS. And this will go ahead and generate the IPA via Cordova itself. So build succeeded, and then I can say Ionic emulate iOS. So this is it leveraging Ionic for the framework itself. It's going to go ahead and integrate with the simulator itself. If you ever get something like this, Command 4 kind of shrinks it down, so that helps. So here's Ionic, and this is the tabs template. So down here at the bottom, we have the series of tabs, and we have these transitions. And you notice that these actually look and feel native. Like there's subtle transitions that occur with buttons and things like that. But this is, don't fool yourself. This is actually utilizing markup, CSS, and JavaScript. So it's meant to look native, but in reality, it's actually just a web app. So that's how it's actually designed that way. And Kenda UI follows that same paradigm as well. So the mobile controls we have in Kenda UI, as well as many other frameworks that target hybrid, do the exact same thing. They theme their UI to look and feel that way. Now, if you wanted to take a look, you could take a look at the code itself. Not you, you. So Ionic creates a similar directory structure. In the case of the tabs application you saw there, you can see we have our directives here. So we have this directive for our Ion nav bar, which is that navigation bar you saw at the bottom. And these will allow you to basically create that look and feel that simulates that live, that native effect in iOS. And there's a whole series of controls that you can target as well. You can see that we're targeting Angular. Sorry about that. You can see that we're targeting Angular, and we have a whole series of services and controllers as well as that we can leverage. So that's essentially Ionic, and you can go check out that on Ionic as well. I am leveraging Visual Studio Code here, and there are a series of tools that you can use as part of this. One series of tools that Microsoft's working on right now is called Taco. These are tools for Apache Cordova, and these will basically be a series of tools that integrate with tools like Visual Studio Code. They provide a runtime environment, a whole bunch of things like IntelliSense for APIs like the camera plugin as well. You can find this at taco.tools. Tools is the best high-level UNC that's out there right now. So if you go to taco.tools, you'll see a page that looks like this. And these are the tools that integrate with Apache Cordova you can download. So it's providing things like IntelliSense and debugging support, continuous integration, development setup, things like that. These are better now than they used to be. This used to be a nightmare getting your environment set up, as I alluded to earlier. But basically, if you go into your debug setting, you can get a whole series of configuration options. So these are setting your environments, one of which you can set here, which is Cordova. This is provided by Taco and allows you to debug, set trace points, breakpoints, get variable values, and things like that. If you've used VS Code, you may have seen this earlier, but there's a whole bunch of different environments that you can use for this. So I won't worry about covering that too much. Cool. So that's essentially hybrid. That's a very bastardized explanation of hybrid. And I do apologize for kind of skimming over it, but I think everyone's heard that story before. In the remaining time that I have left, I do want to target something that is really interesting and near and dear to my heart, which is what we're calling native hybrid. And if you've looked at things like NativeScript or React Native, that's where we're going to be basically talking about here. And this is talking about basically utilizing the native API system for addressing the sort of problem spaces that we're trying to target for mobile. So to kind of understand where we were and why we got here, you have to understand what hybrid pretty much promised and how does that compare to what was available on the other side, which is native. So the hybrid promise here was basically, it looked at the space back in the day, and they said, it would be nice if we could bridge the gap between web and native. And in fact, if you talk to the original maintainers of Cordova, formerly known as PhoneGap, the guys who at Natobi built it, their design goal was to build PhoneGap so it didn't have to exist. Like the design goal of that project was to force browser vendors to get their act together on mobile platforms so they didn't have to exist. The reality is that never really came to fruition, and so they continued to build on, and hybrid was really this sort of dream of bridging the best of both worlds. Now the reality is today is that there's been a bit of not a backlash, but there's been sort of like this experience that developers have had with hybrid, which is it's not as optimal as they would like. Mark Zuckerberg famously stated some things about hybrid. The worst thing you can do is a poor developer always blames their tools, right? So that's not to say that Mark was at fault of that, but basically, like people were having some issues with hybrid. People today still continue to have issues with hybrid, and so one of the things that we're trying to address in others is, can we still have that reality of targeting JavaScript, but getting the high performance that is seen with native? There's a whole bunch of other stats here I won't bother getting into, but the problem is that with hybrid, the problem is the Webview. The Webview is really where a lot of the performance issues are encountered. That's where you see a lot of the jankiness occur, and it's just the web views themselves have really sucked. There's this meme that went around for a while that mobile Safari was the new IE6. You may have read about this online. To a certain extent, it was somewhat true. In some ways, in other respects, it wasn't. But really, the mobile web views themselves have really held us back in terms of what we could do. Up until recently, Android was a complete nightmare. Like the default native mobile view outside of Chrome on Android was just terrible. It was slow. It didn't work well. None of the APIs were there. Thankfully, after 2.3, that's got to be a much better story. But it still remains that there's some problems with mobile web views. So now we're moving towards this world of, rather than going from hybrid being a series of compromises with plugins and things like that and trying to bridge that gap, why don't we try and take a look at a new approach? And so what we're trying to address is this sort of, let's get a fast time to market development experience with this awesome user experience and bridge them together. So ultimately, the design goal for doing this is to have them share those two qualifications. So in the case of web hybrid, you have the ability of sharing code. You have massive skill reuse. You can use existing libraries. On the case of native, with native UI, there's no Webview, so you don't have that jankiness. You have full 60 frames per second. You have full access to device APIs. A new platform comes out, a new version of iOS or Android comes out. You don't have to wait for a plugin to be written. You can target it immediately. Those are true advantages of each platform. Now, one you may have heard of, which is out there, called React Native. And so this is basically one approach that you can take where you're utilizing React as the underlying framework for this. At the initial onset, they had support for iOS. They've recently added support for Android. It is a little bit clunky, but it does work, and it allows you to target this. So if you're a React developer and you like that style of targeting frameworks, et cetera, this is an approach you can definitely take. This will allow you to develop what we call hybrid native applications. The one that we're working on, of course, is NativeScript. Of course, I'm somewhat biased towards ours, so take that assertion with a grain of salt. But I wanted to talk about how these two frameworks fundamentally operate at a low level. So the way this sort of operates is at the top level layer, you have your application code, which is represented on the bottom. It really should be flipped, but basically you have your application code, and when we invoke APIs, we do so via a bridge. So what we're trying to ultimately target is a native API. So in the case of a UI on iOS, that's targeting UIKit, right, which is the UI framework for iOS. On Android, java.star, name whatever framework you wish to target on Android. That's essentially what we're trying to target. And when we do so, we'll do so via JavaScript. And it's because of the evolution of JavaScript runtimes on each of these platforms that enables us to do so. This was not available until relatively recently that we were able to invoke these native APIs. So there's things that we need to do along the way. So for example, conversing metadata across the wire, converting types from their JavaScript to native cousins, dispatching calls directly to the underlying system, and then getting result sets back is really what these frameworks will do, like NativeScript. And so what we do is we generate things like metadata for you, so you can basically interact with these native APIs, but that nothing stops you from writing your own if you wish. So let me show you an example of what this looks like in code. So here's an example that's targeting NativeScript that leverages some Android SDK APIs. So at the top, we have, this is all running in the VM itself. So we basically invoke the Android object. On there is a text.format.time method. And then we can go ahead and serialize out a time object to the console window itself. The output for this is pretty easy, but what we're doing here is we're leveraging that time object directly in JavaScript. That's a native object to Android itself, and in fact, leveraging via Genie on Android. Conversely, on iOS, we have a similar type of API call that's surfaced out through these classes. So in the case of UIKit, there's a structure called UI alert view. You can set some parameters and call a method on it for the show method. And all this is done via JavaScript. Fundamentally, each one of these map to what you would normally see in the SDK docs. So if you've ever been to the SDK docs for iOS, these automatically map to the same sort of properties that you would be used to. So what this means is if you're a JavaScript developer and, well, actually, if you're a native developer targeting iOS and you want to utilize something like NativeScript, you can go ahead and do so simply by utilizing your existing skills around this. So that turns out to be really nice because the SDK docs map directly to the methods that we provide. So in both instances, both of these are running against the VMs that are present on each of these platforms. So in the case of Android, that's V8. In the case of iOS, that's JavaScript core. So it allows you to basically invoke those. In addition to that, once you start targeting native, you start to understand that really there's no compromise that needs to be made in terms of the UI itself. And in addition to that, you get the added win of not only leveraging JavaScript, but having shared code across platforms. So that turns out to be really, really nice. And we've done a bunch of measurements against this. We're seeing high throughput in terms of frames per second. You can see frame rates here at that 60 frame per second sweet spot. Compared that to other frameworks that we've done testing with, like Xamarin, for example, sometimes those things can actually be not as performant as you might like in those cases. Because we're targeting native UI, it really helps. But the third and probably the most tangible benefit of this is you get huge code reuse and skill reuse. And in this instance here, this is a person in the community. His name is Nathan Walker. What he's done is he's actually utilizing NativeScript and Angular 2 to actually have the same code work not only across iOS and Android, but also for web. So he can create a web page, and because of the way that the renderer has been drawn out by Angular 2, he can actually emit not only HTML, but a dialect that we support, which is an XML dialect in NativeScript, we'll see in a second, to output these native APIs. So this is a native interface that you're seeing on the right for both Android and iOS, and that is an HTML interface that you see on the left there, targeting within Chrome. So let's take a look at what this looks like in code. I'll jump over to a demo now. So if you want to install this, you can do so via npm. So let me just show you how this works. So you'll say npm install, and then you'll say NativeScript. We alias this to something called TNS, or Telerik NativeScript. So TNS, this gives you the usage for this, and it's similar to all the CLI tooling that you've seen so far. We do have tooling as well that integrates with Visual Studio, as well as Sublime Text and Visual Studio Code, and a whole bunch of other environments. There are other toolings that are also available for other platforms as well. So I'll go ahead and say TNS create, and then this gives you another description for how to create projects. So we have a bunch of parameters here that you can specify. So here I can say, give me one that utilizes TypeScript. So just as a side note, NativeScript was implemented using TypeScript. We're huge fans of TypeScript. So you can emit a project using TypeScript if you wish. You can use one that utilizes an Angular template. So that's using this -- template option here if you wish. So there's a lot of options available to you. To keep this simple, I'm just going to go ahead and say TNS create, and I'll say NDC. I'll say TNS NDC 2016. And then from here, once I specify that, by default, we assume just JavaScript. We'll go ahead and emit a project and lay it down on disk, and then from there you can go ahead and start working against this, and I'll show you what this looks like in a sec. In some cases, we have to dynamically download resources from the internet, and so because we're on a slow connection here, in some cases it can be a little bit slow. So let me jump over to a project I created earlier. So let's see, what do we got here? CD TNS, let me see, 2016, or say Sydney rather. So let's take a look at what this looks like. So this is a project I created earlier. This is targeting NativeScript. So what's been laid down on disk looks somewhat similar to Cordova, but one big difference you'll notice here is that instead of having a file here in HTML, we're utilizing an XML dialect. Why are we using this? Well, if you've done any work with React, this is very similar to JSX. The only difference here is this lives as a standalone file. We can certainly do this with Angular 2 if we wanted to. We can actually have the XML dialect itself appear within our component if we wanted to do so. But in this instance, what we've done is we've defined an XML dialect, and each one of these items that you see are like page, stack layout, label, button, etc. They all map to their native counterparts on iOS and Android. And so in a second, you'll see how we do that. But inside of this description, you'll notice things that make it quite nice. So we have things like event binding. We leverage the new event binding and property binding syntax in Angular 2, if you're utilizing Angular 2, by the way. But in this instance, we're just doing event binding, property binding, to an underlying class called an observable, which is defined in NativeScript, which is more information than you really need to know, but it's there if you wish. In addition to that, we have our JavaScript files associated with this. So in this case, we have an event model. We're leveraging the ability to access these properties as well. This is our view model that we're utilizing for this. And all of this is just basically packaged together to basically output a native app. So how do we do this? Well, we'll go ahead and say TNS build iOS, and this will generate for us an IPA. And rather than running this off the command line, I'm going to show you how this actually looks in Xcode. So to show you kind of like how the sausage is made, once we do this, you'll notice that there's a platforms directory here. And inside here, I've already created one for Android. But down here, you'll notice there's our Xcode project. Now, one thing that differs from React Native is that we don't basically need to utilize the Xcode environment, the IDE itself, to run projects. But I'll go ahead and do so anyway. So I'm going to go ahead and open platforms, and then I'll go ahead and open TNS Sydney, that project there. So I'm going to fire up Xcode. Apologies if you don't like Xcode. I think it's OK. I like storyboards, but whatever. So if we take a look at the project itself, here's our file structure. If you haven't seen this before, don't worry. It's not too scary. But here we have our assets for our application. So the JS file, the XML file, et cetera. We can go actually ahead and launch this to target the simulator that we have available on our machine. This is one of the outputs that we generate, but you can certainly do this directly through the CLI as well. So what we're going to do here in a second is we're going to go ahead and deploy this application via Xcode to our simulator here. But one of the things I want to show you is that this is a truly native application. I'll see why in a second. So I'm going to go ahead and let this launch. And you'll see the sort of default project that we create. It's nothing special. It's a very simple application that we create. Sorry, the scaling on this is a little missed. So very simple, nothing magical. But the thing I wanted to show you is if we jump over to Xcode and we say debug and say capture the view hierarchy, this is where we take a snapshot of what's in memory. And you can see here that actually these are native controls. This is actually a UI button label, which is from UIKit. So these are native controls that have been emitted to UIKit. And you can see that this is not a web view. These are native controls that are being emitted. Now, to understand how this operates, you need to understand a little bit about how NativeScript works itself underneath the covers. But what we effectively do is we did a JIT compilation, and we convert the XML into the native types that they represent at runtime. We do that hit once, and then we simply run at basically full speed ahead at the native level when we run our application in this way. So this is showing you how that operates. And I can do the same thing for Android as well. So if I wanted to run this off the CLI now, I can say TNS emulate Android. And using that same code, it's going to go ahead and generate a APK file, which is the app package for Android, and go ahead and deploy it to the Android emulator I have installed in this machine as well. We also support Genymotion, if you're into that as well. But essentially what we're doing here is we're kicking off a Gradle-based build. And we can integrate with things like CocoaPods on iOS. We can integrate with jar files. We can integrate with all kinds of plugin libraries as well if we wish. But essentially, that's really what the tooling provides. The Android emulator itself is pretty slow, so you have to be kind of patient with it. But the idea here is that I can go ahead and leverage the same native features that are available to me. Now, while this is firing up, one quick thing I wanted to, well, actually, that went faster than I thought. Maybe this will fire up. So 2 emulators, this is like dogs and cats living together, mass hysteria, Ghostbusters type thing, right? I've never had these two talk to each other, but yeah. The other thing you can do is you can deploy to a device. So you can actually, it will show you a list of devices you can deploy to if you wish, and that includes iOS and Android. And we have technology called LiveSync, which allows you to basically do live updates to the UI as well. So I can make a change, and then through a file system watcher, we'll trigger that change and then immediately deploy to the device or emulator that is connected to through LiveSync. Should really turn off notifications. There you go. So this is a native application. This is an APK file deployed to Android. So great. Trace statements. I'm going to kick through both. Trace statements will be emitted to the console as well. And there's a whole bunch of plugins that you can use. But one thing I wanted to show you here is, if we take a look at our project here, you may wonder, like, where do some of those types come from? Well, we actually have inside of our nodes modules, that's great. Inside of our nodes module here, we have this subdirectory called TNS core modules. And this is what we ship. So similar to how Cordova ships things like the camera, the accelerometer, contacts, plugins, we have similar core modules available in NativeScript that you can use as well. So for things like connectivity, for things like integrating with a debugger, HTTP fetch, file system access. Down here at the bottom, if you notice, we have a section here for UI. These are all the UI constructs that wrap our native cousins, if you will, for things like HTML view, list view, placeholder, progress bars, et cetera. And those will map one-to-one to those entities on the native side. How do you turn off the notifications? This is not good. This is like total demo fail. I apologize. Do not show notifications. This is like a Chrome thing. I never turned this off. I apologize. I'm sorry. All right, if it pops up again, great. All right, what do I do? This is great. This is going to show up. This is going to show up. Stop. All right, what do I do? Someone tell me. I don't know.
Halfway down.
Halfway down, okay. Pop-ups.
There you go, notifications at the bottom.
Okay, it says do not allow any site to show notifications. Why is it showing me notifications? Stop. Okay, just ignore what's happening on the right, okay? Just ignore it. I know it's hard, but so we have all these modules here that you can use for this. I'm just going to keep the cursor there, and I'll just click it. So we have all these things, including a Webview. So you can embed a Webview, if you wish, into your native app, and we'll utilize UI Webview on iOS. There's a Webview component you can utilize on Android. These are the native constructs that are available there that you can use for that. And so it turns out to be really nice in terms of that and what you can do. Now, a lot of these things map almost one-to-one in terms of what you can do on React Native. It is a little bit different, though, so just be aware of that. There are some things that differ in terms of there. But the development experience for this is quite nice. So there's lots of things there. In terms of plugins, if you go to NPM, we have over 308 plugins. I've written a couple myself. There's one called NativeScript Sound that allows you to play sounds in your app. These are just, this is how you utilize it. So we have TNS plugin, add NativeScript Sound. And then the way that you integrate with this is you just say require, and then you simply call the APIs that are exposed through that. So it turns out to be pretty easy. I'll show you an example of an app that does that. Let me just jump over to my phone. And I'll fire up, for example, something like this guy. Come on, guys, just shut up. All right. So this one you may not be able to hear. Let me make sure my volume's up. I'm plugged in, that's why it's going to be problematic. Would you guys please mute? Thank you. So what you're not hearing there is, these are wind chimes, and there's actually a bunch of sounds that are being played. I don't know if these will actually broadcast through my laptop. Yeah, the problem is I'm plugged in here to display it through QuickTime here, so it's kind of a weird setup. But this is a wind chime app that utilizes a sound player. These are playing MP3s as part of that. There's a whole bunch of other examples you can take a look at. I'll show you another example here. This is our sort of kitchen sink app for NativeScript. These are all native controls here that you can use. Let me go ahead and center this guy. So we have things like layouts that you can use. So we have various layouts that you can leverage as part of this. These are all native controls, but they're all represented as XML, leveraging underneath the covers JavaScript for this. You can create some really nice designs. No jankiness with this as well. Because it's coming through QuickTime, it might look a little bit janky, but it's buttery smooth on my phone here. So we have things like charts that you can use as well with full animation, 60 frames per second for this. Item layouts as well. You get the idea. And you can take a look at the code for this as well if you want. So this is the XML file that maps that. If you've done any work with XAML, you'll feel very comfortable in this environment. That was intentional, by the way. And so some of these things might be difficult to do in a hybrid sense, but in a native sense, you're still leveraging JavaScript, you're still leveraging XML. It's actually quite nice for this environment. So I have 6 minutes left, so I will jump back to the slides and quickly go over a few last things, and then we'll wrap up for any questions if you guys have. So there's a whole bunch of frameworks you can use for targeting UI. There's this framework called ACE. There's a whole bunch of other ones. You'll also get sucked into this debate of React versus Angular. I wouldn't worry too much about that. Just go with what makes you happy. If you're leveraging existing skills, I think that's the most important part. That's the first step. Of course, me working for Telerik and Progress, I would encourage you to take a look at NativeScript. Everything is open source. You can go check it out. up on GitHub. In terms of UI frameworks, there's just a ton of them that you can use, including jQuery. DevExtreme has theirs. There's Onsen UI, Framework 7, a whole bunch of them out there. We have our own called Kenda UI. So just take a look at those and consider what's available. If you want to find out more information about these and other sorts of things, you can go check out them up on GitHub. A lot of these things reside there. So for example, if you take a look at GitHub/NativeScript, you'll see all the repositories for our modules. You'll see all kinds of examples. We also have some examples there that leverage Angular as well. So if you want to go ahead and leverage that as well, you can do so. We have quick start guides. We have a whole bunch of things. You can find everything up on nativescript.org, which is the homepage. This should hopefully be your homepage. And up there we have a resources list. We have videos, we have tutorials, we have quick starts, all kinds of stuff there. There's even some guides up on Pluralsight, so great stuff. Definitely worth checking out. Cool. So I have 5 minutes left, and I did want to hold some little time for questions. So are there any questions? There's a question here at the front. I can repeat, it's fine. Go ahead.
You mentioned all the stuff from the XML gets translated to native controls.
Yes.
What about the code, like on-completed events? How do they?
Yeah, so the question is, in the sample I showed, there was XML that got converted to the native controls. What about the code itself, like the on-click and all that sort of stuff? That does not get converted. It does get JIT compiled. But if you are actually crack open the IPA, those assets still live within that app package or the APK, and they're still run against the VM that is hosted within your app. So there's the native container that's hosting the VM, the JavaScript VM, that's still running itself. It's JIT compiled, and once it's JIT compiled, it's resident in memory, and it will run at the native level for that. I talked a little bit about the bridge that we provide for interfacing with native. That's really where a lot of that heavy lifting is done, this thing. So this is running inside the process space, if you will, of your app on the device itself. But none of those assets change. We don't cross-compile. We don't do any translation, anything like that. Those assets live just like they reside on disk. They are resident within your app package.
So if the on-click button actually hides a button or hides like an element, that actual hiding, the re-render, how does that happen?
So the question is, if I, for example, have an event handler that would modify a UI aspect, like a hide operation, for example, how does that work? That will modify the visual tree represented on the device you're running on. So in the case of Android or iOS, it will interface with those native APIs. So we'll call hide via UIKit on iOS, and then remove that from the visual tree. That's why I showed you that capture hierarchy in Xcode to show you that that's what actually is resident in memory when it's running. And those calls will simply interface with the native APIs. So if I call hide on my JavaScript application code, that will invoke the native API to call hide on UIKit on iOS, for example, and then remove that element from the visual tree on iOS, for example. There's 2 questions here.
When you were testing on the device for iOS, do you need to be a member of the developer program?
So the question is, do you need to be a member of the developer program to test against iOS on the device? If you're going to, the answer is not necessarily. It depends. The reason why I say that is because if you're going to create IPAs, for Cordova, you need to have a provisioning profile if you're going to create an IPA. In the case of NativeScript, you can sign after the fact, if you will, but we'll create one for you and deploy. It depends on how you have your device configured as well. There's a whole bunch of different settings that get involved there. So truth be told, if I get a provisioning profile and a certificate to work against, that's the extent of my knowledge in terms of all that mess. Like, it's a total mess. Like, I've spent days trying to get the right provisioning profile down. Oh, I forgot I wasn't targeting the right, domain space for this. It doesn't match. And if you've ever done any of that work, it's just a nightmare. And also, that's just on the iOS side. If you want to sign, for other stores, for example, like Google Play, it's a different story altogether. So that part still exists. That part is still problematic, but the CLI will help you in every regard. So most CLIs for most tooling, the stuff that I showed you, Cordova, Ionic, React Native, there's a React Native CLI, NativeScript, there's all stuff for doing signing, generating builds, deploying, etc. So the question is, have we done any performance benchmarking against true native APIs? The answer is yes. The team has published some metrics around that. We have some internal testing that we do constantly. We've seen really good performance for the basic sort of operations you would see, like sorting, type operations running. The JavaScript VMs themselves have gotten so fast that it's really hard to tell whether or not you've got any performance degradation at all. I mean, like they're optimizing so well, and they are operating when it's JIT optimized. I mean, it's like running native at that point. So, yeah, I mean, it's really hard to do comparisons now because of JITting. But the benchmarks we've seen so far are fantastic. I mean, getting 60 frames per second. We're seeing operations like in the tens of thousands for very simple operations, but there's no problem for writing these apps. Now that being said, if there's certain classes of applications you probably should concern yourself with, like if you're targeting gaming, Unity is probably going to be a better choice for certain classes of applications. If you're a C# developer, Xamarin is clearly a good choice for targeting that. I'm not advocating that you switch gears entirely and stop doing C# development. Do what makes you happy. But if you're going to target JavaScript and you want to leverage like node modules that are available, as well as JavaScript itself or TypeScript or Angular, etc., and you want to have that code be portable to the web potentially, which we have examples that show just that, then that's a good choice for that. Gaming is in and of itself its own class has its own problems. There's a whole bunch of other problems that get involved with that, like audio playback, for example. The audio plugin I wrote is very basic. Like it just does a simple playback. When you start interacting with it in a very high-performant way, like it struggles. I'll be completely honest. I didn't write the thing very well. So, but yeah, I mean, if you're writing line of business or you're writing sort of like vanity apps or reasonably complex apps, it's super productive. It's really good for that sort of class of. Yep. So the observation is by this gentleman. He said, like, I'm thinking of writing applications that utilize sensors, real-time information that's coming back from the device. Yeah, I mean, like that's totally fine. The latency on this is not like it's not bad. Like I'm not advocating that it's bad, but it's going to be. It's not one-to-one with native, but it's pretty damn close. Like it's really much closer than with hybrid, for example. And you have the added benefit of if you want to write a module, you can do so via JavaScript. You don't have to. That's the big difference between plugins on Cordova and modules that you write in NativeScript. For example, you write your NativeScript modules that interface with native APIs through JavaScript or TypeScript. You don't have to write Objective-C or Swift or .NET or Java for plugins. You write in JavaScript the whole time. And so if there's a native API you wish to target, you can go ahead and do so. And so there might be like high resolution timers that you wish to interface with. We have one that's integrated with that through our trace module, and they're super fast. I mean, they trace down right to the nanosecond almost, So really, really good. And so the accelerometer works really well. They get 60 frames per second on the interface. I'm over time. Thanks a lot, guys. If you have any other questions, stick around. Thanks.